Hello guys. So perhaps I'm the only person on Earth who has not noticed a dramatic change that is going to influence the way we know AtCoder. Because today I logged on Kanku, which is an awesome resource for viewing your AtCoder stats, and I couldn't help but notice that there are problems G and H for the first time in AtCoder beginner contest history. Now, AtCoder beginner contest format changed several times in the past. If you've been around for a while, you probably know that somewhere around 125th contest, there were only 5 problems, and it was really for beginners. And it got more and more complicated. Well, 2 more problems were added, they were sometimes quite challenging and stuff like that. And actually, if you've been around for an even longer time, then you probably know that somewhere around here, AtCoder beginner problems were available only in Japanese, and in fact I actually had nothing to do and tried to use Google Translate to solve some of the other ones. They are different in not only language but also in spirit, so modern problems are quite different. But interestingly enough, the duration has not changed. So the contest itself clearly became more challenging. And because I missed the contest itself for, I don't even know why, but that happened. So now we got to solve it. We probably won't fit within the original time limits, so we'll see. Maybe AtCoder beginner contest will get longer in the future. I'm not sure. I don't think they would probably done it the very first time, but we'll see. So let's get to problems. I haven't done AtCoder in a while, so okay, yeah, I guess I remember this. Okay. I mean, I remember how to open all problems in the same window and stuff like that. So problem ALA, and it looks like I was just wondering. No, okay, unfortunately. So the problem statement is as follows. Takahashi melted and mixed 8 grams of gold and B grams of silver. For whatever reason you want to mix them, I would not recommend it. I believe they cost more on each on, without being mixed with another metal. But anyways, so AB, some of them may be 0, but the sum is at least 1. Okay. To produce new metal. What metal did he produce? Pure gold, pure silver, or an alloy? Alloy, I believe, is like a mixture, but for a metal. So, okay, that is not particularly interesting. As one of my friends says, some problems for beginners, they just involve translating English into code. That's all you need to do if you want to successfully solve those problems. If A is equal to gold, then okay. You have to be a bit careful here, but it is not if A is equal to 0, A is the weight of gold, then the metal is silver, because there is no gold and the metal is silver. If B is equal to 0, then we can output gold. Also, we can output alloy, and we'll be extra nice and give them a new line character at the end. You don't want to put it everywhere here, because I will just forget it once, and if, for example, the problem had test cases, which I believe AtCoder problems usually don't, but still, That should be fine, like, no matter what. I don't even know what to say. Like, just translating English into code, and we get accepted just like this. So that's kind of accepted for like a contest with 8 problems and 4 beginners. Problem B, weak password. We are given a 4-digit PIN code, which may begin with a 0. That's normal for PIN code. The PIN is said to be weak when it satisfies one of the following conditions. All the 4 digits are the same for each integer I, such that xi plus 1 follows xi. Here xi follows 3. 0 follows 9. Okay, so basically there are not so many passwords. Let me read a password as a string. I don't think that it matters. Okay, so how are we going to do it? There are 2 cases when when the password is weak. So I will be extra cautious to write everything down. But the idea is like it's either something follows, like every digit follows the previous one, or all digits are the same. So what we will print, if like we could also say like weak is same or follow, and if weak, and we print weak, not surprisingly, otherwise we print strong. Once again, no need to do this. Usually like modern checkers are ignorant to white space, but keep in mind that some older ones may not be, so that's on you. So our idea is like loop over all positions. I guess I can just call it I, and you will understand, right? So the length is 4. So we loop over all positions and we say like we want all digits to be the same. What is our condition? That all digits are equal to the first one, right? The first digit specifies the password. So we could do it the other way around with string comparison, but we'll do it this way. So what we want to check is that the string at I is equal to first for all i's, which create variable all that checks exactly that. Originally it's true because there were no digits to examine in like usually conjunction of an empty set of Boolean expressions means true, and disjunction means false, I guess. Yeah, something like that. So we check that first is equal to i's entry of the string for all I. We say like this should be gets its current value and this. If any of those fails, then all will be false. And we then check if all is true, then we should turn the same on. More or less the same thing goes on here. Let me copy paste, but be extra cautious. So here should be follow. But here it should be a bit different. So Si is expected to be first plus I modulo 10, I guess. Yeah, something like this makes a lot of sense to me. I don't know what changed there, but it's okay. I guess there were also other ways of doing the same thing, but we'll go with this. Okay, got accepted. A bit long code, but still nothing like smart. Just checking. I guess you could also like, generate all weak passwords and then just check if it is in the set. Because there are not too many weak passwords, but so. So problem C, minimum difference, we are given two sequences consisting of n positive integers and A. Okay, one is n, the other one is m. Find the minimum difference of an element of A and an element of B, that is minimum over the, okay, not particularly interesting. Okay, so imagine we put all of them together in the same array and sort this array, then clearly makes no sense to take the elements which are not adjacent, right? Because they are kind of further apart and the adjacent ones. So we should look for all positions I and I plus 1 such that they come from different arrays and just check minimum of those. So overall complexity is log of n plus m times n plus m. Let's do just this. I will get another, like I will sort a vector of pairs because actually I could sort both of them on their own and then like be careful, like to perform a merge sort, the merge step myself. But I don't see a specific reason to do that. Apart from that is a good practice for myself. I don't know. Should I do it? Like generally speaking, I would argue that implementing something that you can use from standard library or from your own library, implementing it again is bad practice. Even in the context for sure. During practice, not so sure, but probably still bad. So what we'll do instead is go like this. AI and let's say 0. I go for BJ in B and I say C and place back BG1. So that then I am able to sort the vector C. The second argument does not really matter. You can prove it formally, but we want that. Like even the second element can get involved into comparison within sorting, but that's still fine. And because then you have a difference of 0 guaranteed. And they're kind of interested in minimum, so what we do as usual, we initialize with natural element, which is positive infinity in this case. let's go with this. So if ci first, the second, ci minus 1 second is not equal to ci second, meaning that they come from different arrays. Then I want to take minimum of the difference of first elements, which are actual elements. Looks legit. I don't know. Yeah, probably like this. Elements are not long, so don't see why this could fail. Probably it can, but we'll see in a second. In a second. No, it looks fine. Okay. Probably can speed this up a bit, but won't care too much about it. So problem D, querying multisets. Takahashi has many balls on which nothing is written in one bag. Initially the bag is empty. Okay, so Takahashi has balls without any text and empty bag. Sounds kind of sad. Takahashi will do key operations, each of which is one of the following three types. Write an integer xi on a blank ball and put it into the bag. For each ball in the bag, replace the integer written on it with an integer plus xi. Okay. Type 3, pick up the ball with the smallest integer in the bag. Record the integer written on this ball and throw it away. Okay, so there's nothing smart about it. Like, it's a common idea that sometimes if you have a bulk operation to be performed on the entire data structure, and you can kind of store it away in like a singular variable that will denote whatever is delta that you own to add to a set. So what I'm thinking about is like conveniently they told us that this is a multiset. So let's see. Well, we should create. Okay, so we'll have a data structure that has like it is a pair of multisets initially empty, and also let's say delta that is also, because it is original 0. Then we have a type of the operation. And what we do is the following. So first is write an integer xi and put it into the set. So you read this. Now what you may be tempted to do is just put this, but be extra cautious that you have it. Like all elements in multiset are delta lower than they should be, so the same has to apply to the newly added element. Here we again have xi. That means that we want to increment delta plus xi. Delta actually can be yeah, this can belong and this can belong. Because over multiple operations you can add 1 billion several times, and is it guaranteed that at least, okay. Oh, there is not much to it actually. It's not a pair, so we'll just print this. I guess this is this true? Yes, of course we have to add delta. I don't think that this matters. I think that like this is unary operator should have higher precedence. Yeah, actually, let's test my knowledge of logic, I guess. Okay, so that is also correct. So yeah, we keep like all delta changes in one variable, because why would you go over the entire set if you can just perform them on a singular variable? So like all elements in multiset are delta lower than they should be. And we do this because operations with delta are super quick. We have to not forget that that elements are delta lower than they should be. So whenever we take elements, we should add delta. Whenever we put element, we should subtract delta to compensate. Right, so make it, I don't know, like, imagine the delta is like, this is a club and delta is how much you pay to be in the club. So like but when you get out of the club, you get your delta back. Sort of. Works like staking in cryptocurrencies. Guess that helps you. So we can keep like all but staking, but all parties have the same stake for some reason. So you can keep this stake, like don't keep the track of it exactly for each party. You can just say like, okay, then there's one variable that specifies how much you have to stake. What is the entry fee for the club? From e-safety journey, the Republic of AtCoder has n cities, so it's a graph problem. And surely there was a bidirectional route between every pair of different cities. That's kind of expensive, given that n is up to 5,000. But m of those routes have become unusable due to the deterioration over time. How unfortunate for the Republic of AtCoder. That's really unfortunate. More specifically, for each I from 1 to m, this route connecting city UI and VI has become unusable. Takahashi will go I don't understand why. Oh, because at most 5,000 road. Okay, so like almost every road is present. Okay. The Takahashi will go for a K-day trip. It's a bit late here. Later than when I recorded the video for the yesterday. The Takahashi will go for a K-day trip that starts and ends in city 1. Formally speaking, a K-day trip that starts and ends in city 1 is a sequence of k plus 1 cities such that a0 ak equals 1. For each I, ai and ii plus 1 are connected by a still usable route. Print the number of different K-day trips that start and end in city 1 modulo something. Okay. I wonder what stops me from... Oh, okay. Now that definitely stops me. For a second I thought that I can just perform some I guess dynamic programming, but turns out that it's not so simple, as we will see in a moment. NMK. Okay. So we read our input, which is actually not a graph, but the complement of the graph, but whatever, like, So what I wanted is to have a dynamic programming for each city, how many and each number of days from 0 to k, to know how many trips there are that start from city 1 last given number of days and end in a given city. Now the number of values to that dp is 5000 squared, which is acceptable, so of nk. The problem is that transitions okay, yeah, so like normally you would say that you need the number of edges in the graph transitions per day, which is unacceptable because that's of n squared k, but you can clearly see like the converse. Like we said that we perform all trips from all cities to all cities. That means that we have to update dp at city with sum of all dp values on the previous step, but then we subtract back the bad routes. So yeah, that sounds about right. Okay. So we have, I should start with that one. So first is day and second one is city. So dp at 0, 0 is equal to 1. And what I want to print is dp at day k and city 0. Now in between those operations, many interesting things happen. We will have a loop over days. I have a loop over cities, so that's like, because we need dp at ij to calculate this sum, like how many ways in total. As I said, it's kind of an inclusion-exclusion formula, but like simpler version. Like we counted something that we should not have counted and we take it back. So first of all, we take we count the overall sum. What happens is this, like we say, okay, dp at I plus 1 j is equal to s, right? But then what we do is we say like, okay, now actually for every L that is in J, in the graph of J, we say, you know what, no, like we should not have counted that. So we will subtract that value from U. Sounds about right. This one is a safety measure. I don't really know, sounds about right. Okay, that is rather unfortunate. Oh. That is painful. It's for every, okay. That's very unfortunate, but like for every, there is no route from a city to itself, but it's not mentioned in the input. So I guess this was a problem. We assume that there is a circular route from a city to itself, which is not true. Yeah, looks like that was the problem. Okay. Probably could have said, okay, let's not that I really want to, okay, like you can save memory, of course, like 100 megabytes is not ideal because you only need 2 layers. We have a wall post on cloud forces, how this can help you. But the idea is like if you don't want to care too much, and you can just do this. Create 2 vectors per each iteration. I don't think that is the way to go. So what else you can do is you can say like, okay, instead of k+1, we'll have 2. With the idea being that you always, when accessing this index, you always take this. Accessing the first index, you always put this. This way it will go to the even or odd part. I believe that this part ensures that we overwrite whatever was previously there, so there is no need to clear explicitly. We'll see in a second if I did it right. So the code size is a bit longer. You can see that there are 2 benefits. So first, memory usage went down from 100 megabytes to just 4, and second, execution time itself went down a bit. It is usually not a deal breaker, but if you're shaving off some time, then you could also do this, I guess. That makes sense. Problem F, and I believe that, like obviously I don't have access to this, to the problem difficulty during the contest, but as you can see, problem G appears to be easier. which we probably could have guessed. Let's look at the standings. And hopefully we'll be able to tell if this is the case. I did it wrong. I wanted to access virtual standings. So we spent around 30 minutes for first 5 problems. That is not particularly great, and we also got a penalty. So yep, not the first page even. Worse than better. Okay. So yeah, there were 2 people who got accepted on G and 1 who got accepted on F. So you could have guessed that G is a bit easier, I guess. Oh, the input format for problem F is just ridiculously long. Maybe that's why. It's not so great. So many variables. Should we read it? We should read all the problems either way. There are n cities and m buses that go between these cities. The i's bus departs from city AI at time si plus half and arrives at city bi at time ti plus half. Plus half sounds very suspicious, but it's okay. Like, what's the point of not... Okay. Let's just keep reading. Takahashi will travel between these n cities. When he is in city P at time t, he will do the following. If there is a bus that departs from city P not earlier than time t, take the bus that departs the earliest to get to another city. If there is no such bus, do nothing and stay in city P. Takahashi repeats doing the above until there is no bus to take. It's guaranteed that all m buses depart at different times, so the bus to take is always uniquely determined. Additionally, the time needed to change buses is negligible. Here is your task. Process Q queries, the ice of which is as follows. If Takahashi begins his travel in city yi at time xi, in which city or on which bus he will be at time zi. I'm not surprised by this problem not having many solves, because that is ridiculously long. Okay. Even reading it is kind of long. So the first thing that comes to mind is to sort no, that is too much. I'm pretty certain that I can process one query in a reasonable time. But we have 10 to the 5th queries, and this time is no longer reasonable for those under those constraints. So if we want to simulate, meaning that we want to keep track of more or less where each journey is at the moment. Okay. Okay, yeah, sounds good. So an idea that I have sounds approximately as follows. So simulating naively takes of n time, probably of n log n time. Probably of n plus m times log of n plus m time. If you do this for queries separately, then it will take off q times n plus m times log of n plus m time, which is clearly unacceptable. Quite literally not accepted. But the point that the problem setter wanted to make, I guess, is that if you simulate them all together, then each edge or each bus is only processed once. There may be several journeys that take the same bus, but we can batch process them pretty much like 2 problems ago. We batch processed the queries to a multiset. Hopefully that makes sense. And then we can keep track of who is where, which Takahashi is where, at which moment with the joint set union, I guess. Like, because what happens is if 2 Takahashis from different queries decide to take the same bus, then they are merged together forever. Which means that all we need to do is to merge them, pretty much like we do in the joint set union. And so in each vertex of this joint set union, we'll keep information like who is actually there, who is with whom, which Takahashi is parent of which Takahashi. Okay, yeah, I'm pretty sure that I know how to do it. Just need to figure out the specific details. I wonder if it's of any interest to you, however. I guess that for a screencast, it will be best if I pause the recording here, do some off-camera coding that will just take care of all the details and then resume. That sounds reasonable, I think. All right, so for this one, oh my goodness, after not a very long break, only about 2 hours, I got accepted on it with a fairly simple solution, but the implementation is kind of painful. So my basic idea is very simple. Like, we will simulate all versions of Takahashi at the same time. So like, first of course, we have 4 types of events. First event is like the bus starts going from somewhere to somewhere. So it starts going, right? Second type of event is bus arrives somewhere. Third type of event is Takahashi, some version of Takahashi appears somewhere, so that is a query start. And the last type of event is some version of Takahashi which may be on the bus right now. So he ends his journey, so like that's query ends. We will process all of those events quite efficiently. First of all, we gotta sort them by time because we will process them in a sort of sweep line fashion from the events with smallest time to the events of the largest time, which makes sense. we will store two additional data structures, one of which is a map called whoat, and another one is a vector of locations where. So this one is actually disjoint set union. You can see that some code of these you got exposed here, just because it so happened. I can't explain why it happened, but I needed to work a bit internally with it, so that's why vector var got exposed, and therefore decided like, well, whatever, I will expose parent and rank as well. So whoat is a map which stores for each location, so for like every city, in every ongoing bus, it stores all people who are in this location at the moment. So for example, here we can have first versions of Takahashi. Here we can have second. Here we can have an empty set because second just left. Here we can have the third version of Takahashi. Now, it's not very difficult to process all of those events in like n time, q time, I guess. Each event can be processed in q time because we have to update q versions of Takahashi, like each. But so imagine that this version of Takahashi arrives here. So now that's an event. We processed it in whatever way we wanted to. Now imagine that those guys live here. They go on a bus that lives here. We can loop over all versions of Takahashi and move them to the location bus from here to here. That's kind of inefficient. So therefore, our map actually contains a pointer to a vector of all versions of Takahashi. With the following in mind, like we can move pointer, like all operations with pointers are all of one time. The only tricky operation is when they finally arrive and we have to merge all of those guys in. Let me increase this city to incorporate all versions of Takahashi. So now we need to merge two sets. An interesting thing that whenever we merge sets, they never get disjointed again. They never get parted, right? So that's why we have DSU in the first place. And also we can merge the actual vectors of people, the pointers to vectors, with this function, which looks like it takes quadratic time over all queries, but actually that's exactly what DSU does. Like it merges smaller to larger and therefore it works quickly. Now all of this is more or less obvious. Like from the idea point of view, the only thing you have to realize that whenever two versions of Takahashi meet in time and space, they never get parted again. They travel together and therefore you can process them quickly. What that means is that every bus will be processed only once. You only have to process one group of Takahashis going to this bus. That already gives you high hopes of processing all events in O of q plus m time. You have to add plus n, of course, for storing all locations, and therefore we get like almost a linear solution apart from sorting all events, which we have m plus q, I believe. Something like that. Also, merging sets actually takes some time, but that's like q log q, because we merge only sets of overall size q. So, like, the idea was very simple. I just struggled with implementation a lot because I needed to update two data structures. I don't know if you can do it with one. You probably can. The solution is probably very overcomplicated, but it's not like terribly long, all right? it's only 150 lines long. A lot of this is actually like readable. See, if type of the query is if type of the event is query starts, then what we do is we like go to this guy. We say like if this location is not empty, then we got to merge this guy in them. So we have call to union. We can only unite with one of them because they are all already united, so I unite with the last one. You could as well unite with the first one, that doesn't really matter. And we also have to update where he is. We have to update where he is. We have to update who is at that city. So, like this query is actually, this type of event is actually quite short. An interesting thing happens when you have bus starts. We got to go to this bus, got to check the city that it lives. If it's not empty, then all the people have to be merged. All the people at location this city have to be merged to the location that bus. And that location has to be cleared, which we do like this. We technically don't delete all of those pointers, which is of course a bad practice, but whatever. Like, nobody cares in native programming, so we don't care either. Now also, if there were some people on a bus, we have to unite them in DSU. So that's kind of unfortunate that we have to one merge operation here, one union operation here. You probably can combine them, but like I just found writing this wall of code easier than trying to combine two data structures into one. So like you can see that I had quite some wrong submissions, and you may think that most of them come from this wall of code, but that is actually not the case. Most of them come from this guy over here. So I initially said that we just sort the events. Turns out that like if one bus starts and another one ends, then first we got to process the one that ends, because those guys who were at that bus may get immediately to the next one, which is the reason why we have get2. We compare the second element, and I also had to change them so that they compare in the correct order. So actually most of those submissions come from this fact, that I just did not write the comparator in the right way. So like from those three, the reason for them, I believe, is this comparator. Here I was a bit in a rush to get accepted already, so I just made one unnecessary submission, but yeah, you can see that it's practically the same. Those two are a bit different. You can see they made in time in a different time. So this one is actually like I just forgot to remove the debug print, which delete. And then the second bug that I had, I just didn't run the samples. And the problem in samples was that I was not uniting, I was not calling union when adding a person. So I was only calling it here and here, but not here. So yeah, like actually, like if I were more careful, I would have like three wrong submissions. No, actually, if I was very careful, I would have only 2 or even 1 for comparator. Because those 3 guys kinda could have been resolved with just careful thinking about comparator, so that they get into 1 wrong submission, and those guys I just didn't run the samples. I would have found the reason. Also did a little bit of debug, like just printing data structures where and who at completely. That kind of helped. Although that was kind of big output, but I got through it in like several hours time, as you can see. Actually, I only, like, I was debugging here, so only like 20 minutes. The rest I was like half an hour I was AFK, and then I was writing code. And I've been debugging only for 20 minutes actually. So with this out of the way, I wonder if we have enough time to take a look at problem G, because from what I've heard, it is actually easier. Like you can see that this problem is 2300 rated, which is like, it says that our solve probability is 31%, which makes sense because I took 2 hours to solve this problem, so that probably means that I would not have solved it during the contest. Even if you count AFK time away, if you make me like very conscious and not making mistakes, I probably still would not have solved it. Whereas problem G power pair is 2150. Right, so that's exactly 50% accuracy probability of solving for us. So maybe it will be easier. The last one I kind of don't want to even read because it's like 2700, right? Maybe it's because of those two being harder than usual. But man, I don't know. Actually, this one looks easier than this, than this, than this. And all of those, so, but maybe it kind of counts. So what happens here? Let's read. We have modular arithmetics, which means number theory probably. How many given is a prime number p? I love Japanese people. They just speak unique English. I kind of like it this way, more than the usual one. Okay. Japanese are very smart, I must say, and wise. Actually, more wise than smart, if you get what I mean. How many pairs of integers x, y satisfy the following conditions? So they are remainders modulo p. There exists a positive integer n such that x to the power of n is equivalent to y modulo p. P is a prime number up to... Wait a second. What? Heaps? No, I don't want. That sounds more complicated. So we can't, like... Okay. You see, in all of such counting problems, you got to group by something. You can group by x, by n, by x, by y, and by n. Usually grouping by x and y does not work. But how could we group by x? Loop over all possible values of x and repeatedly take their powers until they become 1. Which they do because that's the number p is prime. So every number in some power is 1. sometime, wait a second. So number x gets into what I believe is called order of x modulo p. What we know about order of x is that it divides p minus 1, because of course Fermat's little theorem says that x to the power of p minus 1. Well, okay, like we got to count 0, 0 separately, if you don't mind. So imagine that like assume that x and y are non-zero remainders, then this is equivalent to 1 modulo p, right? And therefore, if x in any power gives 1, then this power must be a divisor of p minus 1. Which makes me want to factor p minus 1. Okay. Ooh. I should not use n because it's already in use. Okay, we'll call it q, although q is usually meant for denoting prime numbers, but still, if this is divisible, then no, while this is divisible, plus f and d, q divide over d. If q is greater than 1, then f at q is equal to 1. We'll create a scope just because we can, so that q does not get like used anywhere else. So that we can use q somewhere else. That was of course what I meant to say. So we factored this guy. Now the question becomes like, we should group by order, I assume. Oof. It appears to me like, so the problem is like, given order of p modulo x, count x. If you can do that, then you're very good. You're very good. Oh, actually, why don't I just... Okay, I don't have to factor. So 1, 4, 0, 0. Like, I need to loop over all divisors no matter what, so what am I doing? This function, its purpose is given order, count how many x have this order. And I believe that we can spend quite some time answering that question. Because there are not that many divisors. The trivial bound is, of course, square roots, but there are more reasonable bounds on the number of divisors. I bet that it has up to 1000 divisors. Because how do you get a lot of divisors? You try this, but that quickly runs out of primes. The following primes are very large. This multiplies the number by 13 and doubles the number of divisors, which you can also achieve by doing this, which only multiplies the number by 4. So actually the number with the biggest, with most divisors looks something-ish like this. Something-ish like this. It does not have that many. So I believe that this function can be quite slow if it needs to be. Prime have a given order. Oh no, I need to know some. That is okay, that is not very interesting. I need to know some math, which I don't know. Wait, what's happening? I don't understand. The problem is that we clearly can't loop over all x, and therefore we have to group them by something. And I assume that we want to group all x's by how many values of y they produce before cycling back to 1. The problem is that I don't know how to count how many elements have a given order. Oh, that's interesting. Like, I believed that we know this fact. Primitive roots, in case you're wondering, are those for which order is p minus 1. And I was pretty sure that we know how to find the number of primitive roots. Counts. Phi of n. Proved here. Not here, but here. All right. I wonder. I'm very tempted to just say that there are phi of order remainders that give a given value of order, that have a given value of order. Because I believe that sum of phi over divisors is equal to the thing that we are looking for. Okay, so now we basically want to we want to compute Euler-Tothian function. Which I'm pretty sure we have somewhere over here. Prime numbers, no? Euler-Tothian function, yes. Square root time. Can't complain. That won't help because n is quite large, so. Probably should have. Yeah, usually you have to provide this thing. The source. I wonder. This should be long as well as this. Also, probably I want actually this to be lambda function because of how the code is structured. That is also a possibility. So, but. this is really what we need, right? Okay, phi of n is not ridiculously large, so we can mod it once, I think. I have no idea if that's gonna work. We probably should test it. Because I kinda... Okay, Q and declares. Q, my friends, is p minus 1. Does not look promising. Does not look very promising. Okay, so we are clearly undercounting. Wonder what could possibly go wrong here. Oh. Okay. Like our order can be 1, but more importantly, it can be phi of p minus 1. Because order 1 is like basically x equals 1. Now we are overcounting severely. So what it says is like there is one number with order 1, which is correct. Then it says that there are 4 numbers. 4 numbers with order 10, which is presumably correct. Let me do one more thing. X less than p. 1 second. Like, we can check our hypothesis. So it says that the numbers with order 10 are 2, 6, 7, and 8. So this number is correct. This number is also correct because this is this. And it says that there is one number with order 2, which is also correct. It says that 1, 2, 3, 4 numbers with order 5, which is also correct. Then there is a little bit of that, which is oof. Oh my goodness. I forgot that we only should low power divisors. Of course it doesn't work if you low power random numbers. Now if we remove this, okay, so the hypothesis clearly works. It just works. I believe that the same book has the reference, like the proof of this fact that there are phi of order numbers, remainders with given order. No? How wrong is that? Let's see. Okay, so that is partially wrong. Interestingly, it passes all samples. I wonder what's the reason. I wonder what's the reason actually. Is it this is too large, or this is too large? It should not be. It's 10 to the 6. Oh, that can be too large. Because it's up to 10 to the 12. Like this can't be too large, but this can. Necessary. Well, hopefully at least this fixes, right? Yes. Okay. So that just I had to learn. I learned some math today. That is interesting math. Kinda expect. I bet I actually heard a proof. I bet it uses roots of unity and cyclotomic polynomials. Anyways, that was a strange problem. Definitely not G, because you can kind of guess that C and T is just phi. Like the previous one was kind of harder. So, I guess that's not bad. I mean, we solved 2 yellow problems today, one of which is like 150 points above our rating, and the other one is 300 points above our rating. As you can probably see here. So those problems are like insanely hard for me. If I was doing it at conf forces, then it means that one of those problems is like 2400 rated and the other one is 2600 rated, which is quite hard. So that took quite some time. That took more than 3 hours. Most of which I was thinking, actually. So hopefully you enjoyed and learned something new. I kind of like the new AtCoder beginner contest format. I think it's definitely not suitable for 2 hours, but who am I to decide this? So with that out of the way, I think this is it for today. I don't know if I will be able to make a video tomorrow. I kind of make them in the evening after the work or in the morning before the work. But usually in the morning I'm more productive, so I'm trying to work in the morning instead. Because I kind of like my work. So that's it. I don't know. Maybe someday I won't be lazy and I will stream something, but like you have to understand that solving those problems on stream is not like possible. Mostly because like when I'm solving a hard problem, I kind of sometimes I just take breaks, I go eat something, which is of course not possible when I'm streaming to go in the different room. So yeah, and in fact, if you look at like Aristo streams, then he considers the stream to be difficult if the difficulty is around 2000 on code forces. And, so yeah, solving 2500 rated problems on stream is kind of like tough. Because on stream you're kind of expected to solve problems and not just think about them. So that's it. Maybe I'm not ready to stream that high rated problems yet. And I'm not that very interested in streaming just very simple problems, which you probably also don't want. So that's it. That's why we are working in a video format for some time. I don't know for how long, but for now it's video format, pre-recorded content. Hopefully you don't mind too much, because hey, like it's still one of very few AtCoder beginner contest editorials in English, even if my English is a bit broken. Because like official AtCoder streams are in Japanese, I believe, which makes it rather hard to understand for English speakers. So that's it. I don't know. 8 problems is definitely better than 6. Because we like solving problems. That's why some of us are there. That's it. Thanks for watching. If you watched up to this point, you're an absolute legend. See you next time. Bye bye.